Hi all, this is Sharad. Welcome to this Slack update. Since the last Slack update, we have made good progress on the bounce detection component, which we have framed as a time series classification problem. We used more than 8,000 frames. Yeah, there's like 8,000 frames here from a tennis match video and detected the position of the tennis ball using the first component of the project, which was the YOLO V4 tiny based object detection model. We have also resolved the issue of zero or multiple detections using a heuristic based approach. We have manually identified the specific frames where the bounce happened. Now this step is a bit subjective as another person may think that the previous or subsequent frame had the bounce. So this brings us to the concept of window frames to capture the bounce. And as you can see here, as we increase frame size, the imbalance in the class labels shifts from being imbalanced in favor of no bounce to imbalanced in favor of bounce. Right. We also created overlapping windows of frames as it increases the overall sample without changing the class proportion. We implemented a dummy classifier as well as a heuristic-based classifier as a baseline. The heuristic we used was that dip followed by increase in y-axis values of the ball coordinates denote a bounce. We also evaluated skTime KNN classifier. skTime is a sklearn type library for time sequence tasks like forecasting and classification. We get a good bounce AUC of 0.93 here, as you can see, for frame size 20. So Aditya will now talk about our LSTM implementation.
In this part of the code, I'll show text processing and model building. So if you look at this file, text files processor.py, this code takes in the output of model number one, which is a stack of text files. Each text file contains the coordinates of the tennis ball. And so if there was no ball in the frame, then the text file is blank. So this code takes in those text file, processes them, and puts them together into one single CSV file and extracts the centroid data from the four coordinates. Thereafter, the one CSV file which is created is goes into this particular piece of code, which is model 2 data pre-processing. The labels are appended, the ground truth labels are appended there, and thereafter a very important operation, which is converting the CSV file into windows. Because trajectory prediction involves making decisions based on prior time steps, we use an LSTM style model in order to make the data available for LSTM or any other kind of sequence model where the output depends on the previous inputs. We need to feed the data in the form of windows. And so this particular code achieves that. Windows are created along with the labels, and those are then passed into a neural network with two LSTM layers, a dropout layer and a final output layer with a sigmoid output, which is 1 or 0, whether the ball bounced or whether the ball did not bounce, right? And based on that, we achieve very good AUC and other metrics. We report on the AUC here, and as you can see, the AUC value on the training set is about 91%, and on the test set is 88%. And that is pretty satisfying to see. And so that's where we are at right now. And we plan to modularize this code in the next week and start putting together the report. So, thank you.